Hello, my name is Lindsay Shuck. Thank you for joining today's Family Office Network's webinar series featuring xBeam. I would like to welcome Dmytro Kovalchuk, CEO and co-founder of xBeam Incorporated, and Alex Kramarchuk, Managing Director at Colton Alexander. Dmytro and Alex will be introducing xBeam and its patent technology for printing three-dimensional industrial metal parts. They will be talking about xBeam's history and accomplishments and their plans for the near and midterm future. At the end of today's presentation, we will have time for Q&A. Please use your questions chat option on your screen to send over any questions you have at any point during today's presentation.
Thank you, Lindsay. Hello, everyone, and thank you for joining us this afternoon. And thank you to Family Office Networks for facilitating our presentation for you. My name is Alex Kramarchuk, and I am Managing Director at Colton Alexander, a middle market investment bank and affiliate of Wield & Company, FINRA registered broker-dealers. Today, we're introducing xBeam, a company that has developed a metal 3D printing system for manufacturing high-quality industrial parts for the aerospace, marine, and the power and energy markets. xBeam has demonstrated traditional and new design capabilities that are more cost-effective than existing 3D metal technologies and traditional manufacturing. The company is fulfilling its first contract orders for pilot systems from leading research and development organizations in the United Kingdom and China. And they are raising $8 million in a Series A round of convertible preferred shares. Today, industrial manufacturers are facing critical choices in the wake of the coronavirus pandemic. For industrial manufacturers, supply chain weaknesses and the need for greater resilience are driving factors for shifting to metal 3D printing. As a result, metal 3D printing is expanding rapidly and capturing market share from non-automated methods of manufacturing. A metal printer, just like a paper printer everywhere and anywhere, is a probability that we consider as highly likely. Joining us from Kiev in the Ukraine this afternoon is Dmytro Kovalchuk, CEO and co-founder of xBeam. Dmytro is the co-inventor of xBeam 3D metal printing, where he leads technological development. He has spent 30 years as a metallurgist in the titanium industry, 15 years developing industrial electron beam systems for a wide range of applications, and 6 years in additive manufacturing. He holds a Master of Science in Physical Metallurgy from the Moscow Institute of Physics and Technology. Welcome, Dmytro.
Thank you, Alex, for introduction, and good afternoon, ladies and gentlemen. Thank you very much for listening to me today and for opportunity to represent our development.
Congratulations on being granted the U.S. patent for your technology a few weeks ago, Dmytro.
Thank you, Alex.
So to get started, could you please tell us about the development of xBeam metal 3D printing technology?
Additive manufacturing was initially developed to swiftly make prototypes and design models. At first, only polymer materials, plastics were used, and their properties were not favorable to real-world applications, even with shortened lead times. So development of metal 3D printing processes became the next milestone in the evolution of additive manufacturing. This opened an opportunity to produce prototypes that had basic properties close to the original parts, providing opportunity to test prototypes under near real operating conditions. Production of original industrial metal parts with lower mechanical properties and less stringent requirements begin with medical applications like prosthesis and dental products. These accomplishments immediately generated interest in the more in-depth implementation of 3D printing to actual industrial manufacturing. Actual production requirements are completely different requirements than prototyping. Manufacturers need uncompromisingly high product quality, simple operation, equipment, affordable materials, and most importantly, reasonable production cost to compete with conventional production methods. Despite many efforts, it has become clear that most existing 3D metal printing methods are not close to meeting these requirements. Our processes demonstrated, one process has demonstrated excellent design capabilities, but only for small parts and with very low productivity. Others means show the ability to produce more significant parts with high productivity, but were rough, resulting in a great deal of post-processing. And most of the equipment and raw materials were very expensive, making these processes worthwhile to a small customer segment where demand for complex shapes compensated for the extra high production cost. From inception, xBeam 3D was developed to meet industrial requirements without compromise. With xBeam, you can take a conventional metal wire from the nearest welding shop, feed it to the system, and quickly produce a final part with a good quality that requires minimum post-processing. We created our technology and equipment with careful thought on how it would fit into existing production chains and manufacturing ecosystems. Our systems can be operated by personnel with skills equal to that of a CNC machine operator. And 1 hour of operating an xBeam 3D printer costs about the same as an hour of running of CNC machine. Our core competency in the design and development of electron beam systems, combined with the experience we have in industrial metallurgy worldwide, resulted in the xBeam 3D metal printing technology that allows us to precisely and accurately deposit molten metal using standard filament alloys, producing the wide range of metal parts at a cost-effective price. Our main objective during the entire life of the project was to make equipment that would address the largest base of industrial customers.
Tell us, please, where you stand in the development cycle and who has validated your technology?
Since 2014, when we had only an idea, and until now, we have completely validated the viability of our technology. We have demonstrated several exclusive technological capabilities. We have demonstrated the capability to make high-quality parts which meet the highest industrial specifications. And we have tested and approved the main technical and engineering solutions in our equipment, and all the operating capabilities of our key 3D printing components, like the electron beam gun, wire feeding, motion control, and process monitoring. Based on those accomplishments in a relevant environment, we have achieved a technology readiness level of 6. All the accomplishments I have mentioned have been vetted by our existing customers and specific prospective customers, each of which investigated the real level of our development before placing their order. In my opinion, signed contracts are the best validation. And we have completed 1 contract in 2017, and now we have 3 contracts in progress for a total amount of more than $2 million. Now we will have to demonstrate the repeatability of our process in manufacturing large parts, and to demonstrate the reliability of our equipment in long-term operations. For this, we will be building and testing industrial prototypes of our 3D printing systems in near industrial environments and making the necessary improvements to reach full functionality and operating perfection. There are our next milestones: to reach the classification of TRL7 and prepare for serial production. These are our goals for Series A, which opens the door to full industrialization and delivery of multiple systems annually.
Please tell us about the history of the company and your experience in electron beam technologies.
Our company was established in 1997, but our history started much earlier. All our business and all our projects spun out from 2 world-famous Ukrainian scientific and technical schools of electron beam technologies and of titanium production. Electron beam guns are the most powerful and most flexibly controlled heat source in metallurgy, opening wide technological possibilities in various applications. Namely, exclusive technical capabilities of our electron beam guns have become the basis of all our development. At first, they allowed us to develop a low-cost and effective technology for producing heavy titanium ingots, which made titanium affordable for new markets and customers. We then applied our technologies to the melting of other metals, for coating of jet engine blades, for refining silicon and noble alloys, and for other applications. In this field, we provided our customers a full set of services, from the design of customized systems up to turnkey installation and after-sales support. We have reached here the ultimate TRL-9 with our electron beam equipment, operating worldwide in real industrial manufacturing. In 2014, we were introduced to additive manufacturing, and we have found that some capabilities of our EB guns are able to solve a number of critical problems of metal 3D printing. So since that time, we have concentrated our attention on this industry, applying our experience and the exclusive capabilities of our electron beam guns to bring additive manufacturing from exotic and exclusive status to established manufacturing practice. Our own funds and the initial seed round of 1 million euros have carried us to current development point.
Could you please introduce us to the team that's responsible for these developments?
Our team is a diversely talented alliance of deep fundamental knowledge. We have 4 PhD, extensive engineering experience in the development and operation of industrial equipment for high-tech metallurgy, and the creativity of a young generation of engineers. There are a few additional words about me. I studied in Department of Aerophysics and Space Research of my institute. This is an important fact because, namely, NASA's attempts to develop metal 3D printing solutions for in-space application have inspired me to dive into additive manufacturing. That is what led me to doing business in additive manufacturing. Our most senior scientist and specialist, Dr. Vitaly Melnik, is the inventor and brains of our type of EB guns. He has developed and implemented many tens of gun configurations for a wide range of applications, from welding of fine electronic components and up to melting of heavy titanium ingots with productivity more than 1 ton per hour. Our CTO, Denis Kreminsky, who leads our software development, gained his experience at Materialize, the leading company in software for 3D printing. Our Vice President of Quality and Certification, Dmitry Ivanov, resident of Norway, who more than 20 years had a business in the global supply of titanium casting. 2 times he went the full path of certification for his suppliers, large full-cycle manufacturers. Now he represents Norway and xBeam on the International Standards Organization and ASTM committees for 3D metal printing. Our financial director, Olena Partsey, is a certified accountant and auditor. She has a legal and economy education and is experienced in the international trade relations and transactions. I would also like to mention and introduce our special team member, Dmytro, a genius in the art of welding titanium. Dmytro was twice awarded as the best welder in Europe. Studying his unique welding technique gives up priceless know-how for setting 3D printing parameters, and this is one of our secrets of the accuracy of our products. His works determine what can be achieved by 3D printing. Finally, we are supported in our development by leading Ukrainian research and development organizations in material science, welding, titanium manufacture, and others, which represent the world-class institutions that I mentioned earlier.
Why is it, Dmytro, that your team is best positioned to produce the desired results?
Our team has worked together for a long time, and that combination of talent and passion has brought us to a relatively advanced point where we have created far more value than others with a lot less. We always had limited resources in our country as far as direct foreign investment. So we have learned to be more diligent and resourceful with what we have available. That spirit will grow further as people recognize the capabilities that our technology provides. Our seed round was funded by one of the most successful entrepreneurs in Ukraine, who built the largest e-commerce network and online marketplace in the country, if not Eastern Europe. His support and belief in our efforts has been instrumental and will lead us forward to new possibilities. We recognize that in some areas we may be less than strong, and in those instances we endlessly look for highly talented and capable executives in global manufacturing, international management, sales, finance, to lead us further into the markets we have identified directly ourselves.
And what traction have you developed with prospective customers?
Everyone in the metal 3D printing business must be from Kansas. They need to touch it, see it, experience it to believe it. And that includes a thorough understanding of the costs, performance specifications, quality of results, and the economic efficiencies, especially since it involves a new technology. So from the very beginning, we concentrated our promotion efforts on demonstrating our capabilities to produce high quality parts and to do it faster and for less than other companies in the market. We were invited to participate in several European and American conferences, where I had opportunities to present our technical accomplishments. All our initial customers for equipment and exploratory contracts I met at those conferences, where they approached me after listening to my presentation. At first, usually they requested outsourced manufacturing of trial parts to look what is inside, to evaluate the results and to compare with the same parts produced by others. And then, when they found good structure and properties, they placed orders. I can say that 2 out of 4 of our first customers placed orders without even visiting us or seeing our technology personally. Maybe I'm wrong, and not everyone is from Kansas. We are going to continue to gain traction by pursuing certifications with global organizations, including global leaders in standardization for space and other industries. We also gain traction by participating in the Horizon 2020 European competition, where we have already won a monetary award, and in other international innovation initiatives. We are going to continue promoting the general efficiency of our technology as a value proposition and unique selling advantage to attract not only R&D customers, but a wider segment of the industrial manufacturing sector.
Can you please tell us what specific products have you designed for the market?
Based on our internal and external market analysis, we have developed 3 simple configurations of our 3D printing systems: small, medium, and any size custom build. xBeam Lab is the smallest system in our product line and is designed for R&D and education applications. The system is designed small enough to fit through a standard doorway, and it can be installed in any laboratory room. What we have discovered is that there is not any equivalent wire-based metal 3D printing equipment on the market for these institutions. At the same time, many hundreds of universities worldwide have already additive manufacturing departments where they're using powder-based systems that use expensive, volatile, and unstable, in some cases, powders that are dangerous. We are going to close this gap, offering the opportunity to explore 3D printing capabilities with affordable, low-cost, and safe standard wire. xBeam Works is going to be our flagship system, as it is designed for wide industrial manufacturing. The usable build size of this system was selected to feed produced parts into most broadly available medium-sized CNC machines for fast machining in the same workshop. The xBeam works has very similar dimensions and infrastructure requirements as the majority of CNC machines have, allowing easy integration to existing manufacturing ecosystems of our industrial customers. And xBeam Grant is a common name of customized solutions, any size, any options, no limits.
And what types of parts can your system produce?
There are many possible use cases for manufacturing parts that xBeam can produce. Our process is most effective for parts with an average final wall thickness from 2 to 30 millimeters. That is a good news that most parts in industry are in this size range. Also, xBeam can serve if somebody needs to produce something in a remote location where the means of heavy industries, presses, stamps, casting furnaces are not available. For example, our technology is able to make a real metal part for immediate usage. Practically all other metal 3D printing technologies, both powder and wire, require a substrate for deposition. And this substrate usually weighs more than 3D printed material. And then most of it must be removed by machining, resulting in additional time and material losses. In this experiment, we have printed a wrench from titanium wire. It took just about 10 minutes. And then we could take it immediately when chamber was open, still hot, and use it direct to direct purpose. This wrench maybe was not ideal without finishing, but remain it was functional. With such capability realized in space, Apollo 13 story will never repeat. Our systems are best suited in aerospace applications, where a lot of complex parts made of expensive materials are used, and high mechanical properties are required. In the oil and gas industries, where again quality, strength, and durability are required. We are also exploring use cases in marine machinery and power and energy applications. I would like to make special accent on our capabilities for space exploration. I already mentioned that xBeam was initially developed for in-space application. I'm sure that some of our features are really exclusive for metal 3D printing in space, in Moon, or in Mars. This is not a direct subject of our round A, but we believe that our nearest development steps will help us to attract attention of this great market and to open an opportunity to make our contribution to space exploration. As for materials, any material suitable for vacuum processing can be used. We have tested already titanium alloys, stainless steels, alloy steels, niobium alloys, all which are available as standard spool of filament. If to summarize, xBeam can be appropriate in all cases when it is the best of available manufacturing options, either as a normal production facility or as an emergency manufacturing solution, when supply chains are disrupted or become temporarily unavailable.
Ernst & Young has calculated that $1.1 billion of investment was made in 77 early stage companies in 2019, concentrated in printer systems manufacturing. Who then are your primary competitors and what differentiates your company?
There are, of course, companies developing other direct energy deposition wire technologies, and they are also targeting the market for medium and large products manufactured with high productivity. There are only a handful of companies in the entire market, which is both strange and pleasant. Strange because tens and hundreds of companies work in other smaller segments, and nice because the potential market size in our segment is very large. The small number of competitive technologies is explained by the complexity of developing powerful heat sources. We differ from our competitors, namely by the source of heating and its capabilities. All our competitors are using heat sources specially developed for welding, laser, electron beam, welding arc as well. Therefore, they are struggling to adopt excessive power concentration to layer by layer processing, where these features is rather the problem than opportunity. This is the same as shaving by a saber. That is possible, but safety razor is more suitable. There is an additional problem for them. They often have nothing to patent, and legal disputes are the norm for many competitive companies. Our coaxial electron beam gun, the X-gun, was specially developed for 3D printing, providing both high power and the ability to control this power precisely and finely. Our processing systems are patented in Ukraine, USA, and China, and have not any close analogs. We have more than 14 years to expiration of our basic patent, and we are adding new inventions to our IPR. I cannot explain all technical differences in such a short time, but for those who wish, I can answer in more detail in written or provide a technical presentation. You are welcome. But I can say that some of our technological capabilities, like making overhangs and holes without supports, deposition upon the wire substrate, and multi-usage of easy detached substrates, which I already showed you, have a critical influence on final performance and cost. After all, the end user is not interested in the source of heating that was used. They're interested in the final result, how much time it took to complete the final product, including all production stages, and how much it cost, naturally bearing in mind the acceptable quality. This is the main indicator in comparing any manufacturing processes. Our development and commercialization efforts are based on such criteria, and we believe that our performance is going to be proven as the best among existing competitors.
And please tell us, who are xBeam's customers and what industries do they represent?
Any manufacturer of metal parts is our potential customer. This follows from our mission to make 3D metal printing a conventional industrial technology available to everybody, anytime and anywhere. That being said, each industry has different challenges which may or may not be solved by 3D printing. At first, we expect to attract the attention of those industries and customers that are most interested in a more economical use of valuable materials, in optimizing part designs and improving logistic chains. The R&D and education sector will have an interest in our product for its straightforward and convenient operation in conjunction with our exclusive technological capabilities. Our systems will provide many opportunities for designing new materials, topology optimization, and investigation of new applications. We also anticipate a healthy market and the sale of our systems to service providers globally.
Research is showing that metal 3D printing is one of the fastest growing additive manufacturing segments and has seen shipments grow at an average rate of greater than 30% over the last 2 years. Why is additive manufacturing attracting more and more attention from industrial customers?
Industry wants to produce exactly what they need, exactly when they need it. We live in an on-demand world today. The coronavirus pandemic has uncovered the vulnerabilities of existing production and supply chains. The demand for final products in many industries has not fallen, and parts and components must be delivered on time to assembly locations. But the global mobility limitations imposed by the pandemic are forcing industrial concerns to adopt alternatives to solve their supply problems. In addition, spirited discussions have been taking place for a long time about reducing the consumption of material resources in the face of ever-increasing demand. This contradiction can only be resolved in one way: to use existing resources more efficiently and to use them exactly where they are needed. The whole concept of industry degrowth is emerging. And within these conversations and discussions, 3D printing occupies one of the most important places and takes on new relevance. It becomes a matter of expanding the type of production and eliminating the concept that 3D metal printing is exotic and inaccessible. As soon as 3D printing technologies can prove their capabilities, ensuring that the basic requirements of industry are being met, a breakthrough in the application will occur.
What is the scale of the market opportunity for 3D metal printers and services?
Metal additive manufacturing is experiencing fast growth in all segments: equipment, materials, and production services. But despite the impressive growth during last decade, 3D metal printing has been quite slow to replace conventional manufacturing, primarily because of the high production cost of finished products. This problem has set over an increase in the development of large-scale 3D printing processes with high productivity that are able to reduce prices and satisfy a much wider market demand. According to all analytic reports made or updated during crisis, this growth will continue thanks to the capabilities of metal 3D printing to meet the transformed requirements of manufacturing industries. The AM market has been growing last years at a compound annual growth rate of 29%. Future growth estimates based on historical data and analyst consensus forecast potential overall market value over the next 3 years to be between 20 to as much as 33 billion, depending on variable factors. The pace and impact of changes to feedstock prices, system prices, and finding a systematic approach to new applications will play a major role in the outcome. I fully agree with CEO of Dmytro, a world-leading company both in CNC machine market and in metal additive manufacturing, who said that the decade of 20s will be the decade of additive manufacturing. By 2025, if a machine shop has 10 machine tools operating with spindles, they should also have at least 1 or 2 industrial additive systems, leading to 20% of production made using additive manufacturing by 2030, spending billions of euros on this type of technology. Let me also point out that annual sales of CNC machines are measured in tens of thousands units. And for us at xBeam, this motivates us to relentlessly pursue our mission.
Customers have a much better understanding of where metal advanced manufacturing is applicable, how to develop use cases, and how to apply those tools for functional prototyping, tooling, and low volume production. What are the existing primary hurdles to implementing additive manufacturing, and how do you solve them?
If we look at the diagram on the next slide here, from the global 3D printing survey made by Ernst & Young in 2019, we see that users worldwide see the main problem in high cost of materials and systems, which then results in a competitive production cost for final products. At the same time, about 40% lack the knowledge to identify feasible use cases, and only less than 20% worry about the quality of produced parts. It is evident that most of the last group of people are not from aerospace. But what this means for us is that the market is ready to implement 3D printing in their manufacturing ecosystems as soon as they get reasonable prices on equipment and materials with normal, not ultra high or special quality. Our process provides exactly what market is asking for. xBeam uses low cost off-the-shelf material, and the cost of our system and its operation looks significantly better than any other systems with similar characteristics. It makes us certain that we are on the right track to meet a high percentage of the market's expectations.
The 3D Printing Media Network reported in early January that the global additive manufacturing market in 2019 generated over $10 billion in revenues. What is the xBeam revenue model?
We are starting with a revenue stream from the equipment sales. In fact, we have already started. We expect to find our next customers among early adopters in the R&D sector. Thanks to their intention to be on the cutting edge of technological opportunities, and also customers in R&D have a more tolerant approach to the long-term reliability of equipment. This market segment can order all three configurations depending on industry, facilities, and budget. But we consider universities as high probability early customers of xBeam lab systems, thanks to its moderate price when compared to any other room-scale 3D printed systems and wide technological capabilities. As soon as we have achieved 100% full functionality and performance under real-world conditions, we will make our systems available to the wider industrial market. When we have built industrial prototypes for testing and evaluation in our facilities and showrooms, we shall immediately start offering services for the production of parts on demand. In any case, these systems must operate as much as the highest capacities to prove their reliability. So the service revenue model will benefit in two ways: successful operation and revenue during the process. Over time, we will add supporting services like application notes, technical support and consulting, R&D contracts, which we are already doing, and staff training. All of these will be the additional revenue sources correlated to our primary system sales. We are planning to expand our own factory of equipment to produce more parts with time, because we will always be the best experts in applying the technology.
Can you tell us a little bit about the financial picture and your milestones for the next 3 years with the completed Series A round?
We believe that market is awaiting equipment and technology like xBeam. Potential demand is high, but we must enter the market with the appropriate readiness level to avoid warranty claims and unintended liabilities. So production and full testing of our industrial prototypes is our first and the most important milestone. That is the key milestone of our next 12 months. In parallel, we need to reinforce and build our team with additional professionals in sales, marketing, and operations. And we will be developing our own service staff for service engineers, application engineers, and sales engineers. We recognize that most potential customers want to see the equipment in operation before ordering. Therefore, we are planning to organize showrooms in the USA and Europe with our operating industrial systems, xBeam Works and xBeam Lab. We already have good locations and partners for showroom placement and operation, both in Europe and America. These showrooms will become the base for our local service infrastructure. We understand that purchase budgets and sales cycles are in planning 1 to 2 years ahead. It means customers engaged in 2021 will return to us with orders in 1 to 2 years. But right in 2021, we expect to secure contracts from potential customers that we already know and have built with them strong relationships around our capabilities. So the result of our Series A investment will be to build and to test prototypes of our industrial systems in an actual operating environment, make ready for serial production, to establish working showrooms staffed with the appropriate personnel to service and support regional customers. We will staff up our team of developers, managers, and service personnel. And most importantly, we will be pursuing operating profitability over the next 12 to 18 months. With these milestones as a foundation, we can start serial production and delivery of our systems.
Why are direct energy deposition wire processes the fastest growing segment in the 3D metal printing?
Because DED wire technologies are most in line with the industrial requirements and commercial expectations of the manufacturing sector. Historically, many developers of 3D printing processes were keen to surprise everyone with some exclusive possibilities. They printed bridges that no one would walk on, printed food, and everything else that could collect a lot of likes on YouTube. Unique parts are also needed, but if you look around, there are very few such details, which means it is difficult to build a business on this. This resulted in a very low share of additive manufacturing in global manufacturing. I agree with the opinion of the ex-CEO of 3D Systems, one of the industry's current leading companies, Mr. Vaimesh Yoshi, who pointed at the following 4 requirements which make 3D production real: productivity, durability, repeatability, total cost of operation. Thus, only technologies which meet these requirements will be viable. DIY technology is able to actualize the real-world conditions and needs of manufacturing metal parts with faster and less expensive production for both mass-produced and customized products. Under this condition, this market can become very large. Our aim is to earn a leading position in this market within the next 36 months.
And if you could, please tell us, what is the value proposition for your stakeholders?
We are sure that the manufacturing market has been waiting for such a technology for a long time, and we intend to satisfy this accumulated demand for a real and viable solution for industrial printing of 3D metal parts. To our customers, we will provide an additive manufacturing solution that fills a void in the market for part size, economic efficiency, technical excellence, and safe and environmentally friendly final parts. For our investors, the value proposition provides an opportunity to enter a fast-growing industry with a revolutionary patented and already validated technology that can replace and/or complement conventional manufacturing. We provide an experienced and skilled management team that has been deep knowledge and experience in real industrial manufacturing, including additive manufacturing, and the strategy that will achieve sales of $59 million by 2025 and drive the company to a projected EBITDA of $23 million. We have not seen in this 3D printing industry any other companies that have achieved this high of technical readiness level of 6 at this early an investment stage with minimum technical and legal risks. Not to be overlooked, we offer an opportunity to join a team of very creative people with open minds in a company that has a soul and drive in the science and in human values. You're welcome.
Finally, tell us, what is the Industry 4.0 revolution?
The fourth industrial revolution is the ongoing transformation of traditional manufacturing and industrial practices combined with the latest smart technologies. This includes smart machines that can analyze and diagnose issues without the need of human intervention. I would like to emphasize that we have not developed just a technology or just machines. We have and continue to develop hardware and software manufacturing solution, which combines the best physical and engineering knowledge with the modern online process monitoring solutions and closed-loop control systems. On the basis of xBeam capabilities, we are developing the concept of self-sufficient manufacturing ecosystem of the future, which absolutely fits the definition of Industry 4. All that you see in the diagram on the screen is technically possible, and parts of this model are already working. Realizing our plan will protect manufacturers in the event of future crises, making manufacturing and supply chains more resilient, and eventually, perhaps all of us will be able to build our own manufacturing ecosystems anywhere.
Thank you, Dmytro, for sharing your accomplishments and goals with xBeam 3D metal printing. Now I'd like to hand it back to Lindsay and see if there are any questions that we might be able to answer. Thank you very much.
Thank you, Alex and Dmytro. Yes, we do. Again, we would love to encourage your questions. So using your questions drop-down option, if you can send those over, and we can go ahead and answer them accordingly. So we do have a question from Tom. It says, which country's law govern the convertible preferred shares, and where is the company headquartered?
I'd like to answer that question. At the moment, the company is based in Ukraine, and when the Series A round is completed, the operations in Kiev will be moved to the United States and be domiciled in the United States under US law.
Can I add, Alex?
Of course, yes.
Yeah, I would say that the project now is placed in Ukraine, but we have established xBeam Incorporated, it's a C corporation in Delaware, with real location in Hudson, Ohio, especially as a holding company for future project development. Because we think that it will be reasonable to remain R&D facilities in Ukraine, because we have school here and high-skilled engineers, development engineers. But as for manufacturing service centers, service providing centers, we are going to follow the most optimal solutions. For example, we are going to establish assembly facilities both in USA and Europe. And again, we already have preliminary agreements with good companies, good producers of equipment. It's from our previous business in electron beam equipment development. So we are going to follow the most optimal solutions to be close to local customers. And from this point of view, we consider USA as the primary market. The share in metal 3D printing demand is the highest in the USA. So we make an accent in USA market. We are going to establish with time, when we have enough orders, assembly facilities. And of course, we are going to start from showroom in the USA and to be the base for development of our service net 24/7 as usual in industry.
We have some other questions. So the question is, the parts look finished. Is that the condition that is produced, or is there finishing required?
It depends on application. So sometimes you can machine only some elements of the part, which is typical for machining of custom product. And metal 3D printing is one of the best candidates to institute custom in many applications. Usually it's quite easy and fast machining on the nearest CNC machine. That's why I made an accent that we are thinking about easy integration to existing manufacturing ecosystems. And as for usually sometimes even no heat treatment required, sometimes recommended, but it depends on material.
Another question, where does xBeam stand with European Union ISO standards?
I can say that now there are active attempts to develop special standards for metal 3D printing, and there are a few standards already approved, including DED wire. One of our competitors reached this milestone, and I can surely say that much properties which is already approved by independent researchers, thanks to our much better controllability of process. So I believe that in titanium the production of large parts, we must be #1 in future. As for other materials, it will depend on more detailed specifications.
One more question, a little bit similar to a previous one. How many people do you employ, and are you open to expansion into other areas in the United States?
You mean in the future?
Well, I guess so, yeah. It doesn't specifically say, but how many people do you employ now, I would imagine? And then the second part, are you open to expansion into other areas in the United States?
In the moment, of course, we are trying as we are only making first steps here, we are trying to use available facilities of our partners who host us where our xBeam Incorporation registered in Ohio. So I can say that we already have facilities and even with infrastructure for metallurgy and even initial staff, engineering staff to run our showroom. And then as soon as we have this base, we shall have an opportunity to hire people. Fortunately, I can surely say many people, many technical people, engineering people in America very like our project because they're able competently compare us with another projects. So we have the list where we can invite people, where we can hire people, we engage people to work to cooperation.
Yeah, there's a clarification to that question. In the future, what are your job creation projections? How many jobs do you foresee directly at xBeam?
In the beginning, to run showrooms, maybe we need about 3-4 persons of engineering staff, service engineers and operators. Of course, we need a local manager in America who will lead sales and who will contact with local customers. I'm saying about first steps. And then following our development, each additional system will generate from 3 to 5 working places because our systems are configured to operate 24/7. And also, of course, dependent on success of our sales, we shall see how many service staff we need to train. And of course, all this stuff must be American.
I have a question myself. 25 years ago, when I moved to Colorado, I visited with a company in Fort Collins that had developed a polymer-based plastics 3D printer. And I was shocked to learn that the price at the time was $35,000. Today, that same kind of printer is available for approximately $300. Relatively speaking, what is the projected price for your 3 configurations of product, and how do you see that over time changing?
In such kind product, in high-tech equipment, the share of human efforts is usually high, but it depends, of course, on number of sales. So the great difference between serial production and customized offers. Now we have difference between cost of components, of hardware components, and sale price about 2 times. And even under this condition, our equipment is significantly cheaper. And but this demonstrates that we have good reserve to reduce price with growing of number of sales of serial product. And it's normal for any business, any industry. And so our purpose to reach $300 for xBeam Lab, $300,000 for xBeam Lab, and $600,000 for xBeam Works.
Thank you, Dmytro. We have another question. What would the investment cover, which I take it to mean what would be the use of proceeds from the Series A, and where would the main operation be located?
The main operation will be located, operation will follow customers. Now we are building our plans on the base of investigation of market, on the base of current market situation. I believe in American market because America is aerospace, defense, space, and wide industry, manufacturing industry. So this was the main reason to establish a holding company, namely in America, and to plan make our main sales center and service center, maybe even research center for technology in USA. Europe also, of course, is a great market, and I consider these 2 markets as the main for us. And as I said, I am planning to establish assembly in USA and Europe because for our equipment, knowing a share of components to get made in USA in America and made in the European Union in Europe. This is important for tax and for service.
What would the use of proceeds, what would the investment cover? What would the use of proceeds be for the Series A?
As I said, we are going to start from building industrial prototypes. It requires funds to purchase components, and it requires to modify our facilities, assembly facilities, to do it in Kiev. Organizing of showrooms. We have location, but in any case, it will require some expenses for staff, for operation. So enforcing of our staff is our next target.
Yes, and of course, all of that information would be available in the documentation and presentation that is available.
Yes, of course. Yes, of course, and all transparent.
Sure, thank you so much. Again, on behalf of everyone at Family Office Networks, we thank Alex and Dmytro from xBeam for joining us on today's live webinar. We will be following up with all of you individuals, so if there are any questions that you do have after this webinar, we would love to answer them. We hope you have a great day, and we look forward to speaking with you soon.